Hello, welcome back to my maths class. Let's continue the topic integration by substitution method. So the first question is integrate sine 2x e raised to cos squared x dx. Here we put cos squared x equal to t. Now differentiate both sides with respect to x. So what is the here cos squared x is a composition of two functions, that is the outside function is a polynomial function and the inside function is a trigonometric function. So here we first differentiate the outside function into differentiate the inside function. So first we differentiate cos squared x into second we differentiate cos x. So the derivative of cos squared x is what? 2 cos x, and the derivative of cos x is what? Minus sin x. So the left side becomes minus 2 sin x cos x dx equal to dt. Okay, we know that 2 sin x cos x is the expansion of the formula sin 2x. Okay, so this becomes minus sin 2x dx equal to dt. That is sin 2x dx equal to minus dt. So sin 2x dx is the term in the given function. Okay, so we replace this by minus dt. So the given function becomes e raised to cos squared x. That is cos squared x is replaced by t, that is e raised to t into sin 2x dx is replaced by minus 2 dt. So this becomes minus of e raised to t dt. The integral of e raised to t is what? E raised to t. So the final answer is minus e raised to cos squared x plus c. Here we replace t by cos squared x. Okay. The next question is integrate the function x squared into e raised to x cube dx. Here we put x cube equal to t. Differentiate both sides with respect to x. So what is the derivative of x cube? 3x square. That is 3x square dx equal to dt. Now we transpose 3 to the right side. So this becomes x square dx equal to dt by 3. So x square dx is the term in the given function. Okay. So we replace this by dt by 3 and x cube by t. So the given function becomes e raised to t into dt by d3. So here 1 by 3 is a constant. Take it outside. So this becomes 1 by 3 into e raised to t dt. So what is the answer? 1 by 3 into e raised to t plus c. Finally we replace t by x cube. So this becomes 1 by 3 into x cube plus c. Okay. The next question is integrate the function tan raised to 4 root x into 6 square root x by root x dx. So here we put tan root x equal to t. Now differentiate both sides with respect to x. So here tan root x. This function is composition of two functions. The outside function tan and the inside function root x. So here we first differentiate the outside function tan root x into, then differentiate the inside function root x. Okay. So what is the derivative of tan root x? Derivative of tan is 6 square. Okay. So this becomes 6 square root x. And what is the derivative of root x? 1 by 2 root x. So the left side becomes 6 square root x into 1 by 2 root x dx. That is 6 square root x by root x dx. Here we transpose 1 by 2 to the right side. So the right side become 2 dt. Okay. So here the left side 1 is the term in the given expression. So 6 square root x by root x dx is replaced by 2 dt and tan root x is replaced by t. So this becomes t raised to 4 into 2 dt. So here 2 is a constant, take it outside. This becomes 2 into integral t raised to 4 dt. So whose integral is t raised to 5 by 5. Finally replace t by tan root x. So the answer becomes 2 by 5 into tan raised to 5 root x plus c. Okay. Okay, so the next question is integrate cos x by root sin x dx. Here we applied a formula integral f dash of x by root f of x dx equal to 2 root f of x plus c. For this we put the denominator as f of x. Then we differentiate the denominator, that is f dash of x equal to d by dx of sin x, that is cos x, that is the numerator. That is, if the function is of the form f dash of x by root f of x dx, then the answer becomes 2 root of f of x plus c. So here the answer is 2 root sin x plus c. The next question is integral cos x by root 1 plus sin x dx. Here also we check the derivative of the denominator, that is d by dx of 1 plus sin x. That is we check the derivative of the term inside the square root. Okay, that is we get cos x is the numerator, so we applied this formula. So the answer becomes 2 root f of x plus c, that is 2 root 1 plus sin x plus c is the answer. Okay. The next question, integrate cot log x by x dx. So here we put log x equal to t. Now differentiate both sides with respect to x. So what is the derivative of log x? Which is 1 by x. So the left side becomes 1 by x dx equal to dt. Okay, is the term in the given function. So we replace this by dt and log x by t. So the answer becomes, so the function becomes integral cot t dt. So what is the integral of cot? Log mod sin t. Finally we replace t by log x. So the answer becomes log mod sin log x plus c. Okay, the next question, integrate 1 by e raised to x minus 1 dx. So first we arrange the function as we add and subtract the term e raised to x on the numerator. Okay, and that is 1 minus e raised to x plus e raised to x by e raised to x minus 1 dx. Now we separate the numerator with the denominator. So the function become 1 minus e raised to x by e raised to x minus 1 plus e raised to x by e raised to x minus 1. Now 1 minus e raised to x, we can write this as minus of e raised to x minus 1. Okay, plus e raised to x by e raised to x minus 1 dx. So here e raised to x minus 1 is common, so we can cancel this. So the first term becomes minus 1 dx and the second one e raised to x by e raised to x minus 1 dx. Now what is the integral of minus 1? Is minus x. And next we check the derivative of the denominator. So what is the derivative of this denominator? We know that derivative of e raised to x is e raised to x and derivative of 1 is 0. So this becomes the numerator, that is integral of f dash of x by f of x dx is what? Log mod f of x plus c. Okay, so this answer becomes log mod e raised to x minus 1 plus c. That is the final answer, minus x plus log mod e raised to x minus 1 plus c. Okay, the next question. Integrate the function e raised to x into 1 plus x by cos squared x e raised to x dx. Here also we know that 1 by cos squared is what? Sec squared. So this becomes sec squared into x e raised to x into e raised to x into 1 plus x dx. Now we put x into e raised to x equal to t. Now differentiate both sides with respect to x. So here we apply the product rule, first function into derivative of the second function plus second function into derivative of the first function, that is x into d by dx of e raised to x plus e raised to x into d by dx of x equal to dt by dx. That is x into derivative of e raised to x is e raised to x plus e raised to x into derivative of x is 1. That is x into e raised to x plus e raised to x equal to dt by dx. So here e raised to x is common, so take it outside. So this becomes e raised to x into x plus 1 is equal to dt by dx. So this one is a term in the given function. Okay, so this becomes, we can replace e raised to x into 1 plus x dx by dt, and this becomes integral sec square t dt. So what is the integral of sec square t? You know that the integral is tan t plus c. So we replace tan t by x into e raised to x. So the final answer is tan x e raised to x plus c is the answer. The next question, integrate 2x plus 1 by root of x squared plus x minus 15 dx. So here we differentiate the denominator term, that is d by dx of x squared plus x minus 15. What is the derivative? 2x plus 1. So numerator. So Here also we apply the formula integral f dash of x by root f of x dx as 2 root f of x plus c. Using this formula we get the answer as 2 root x squared plus x minus 15 plus c. Okay, the next question, integrate sine of tan inverse x by 1 plus x squared dx. So here we put tan inverse x equal to t. Differentiate both sides with respect to x. So what is the derivative of tan inverse x? It is 1 by 1 plus x square. So the left side become 1 by 1 plus x square dx equal to dt. Okay, so here we replace 1 by 1 plus x square dx by dt and tan inverse x by t. So the function becomes sin t dt. Okay. Now the integral of sin t is minus cos t plus c. Replace t by tan inverse x. So the answer becomes minus cos tan inverse x plus c. Okay. The next question, integrate the function e raised to tan inverse x by 1 plus x square dx. Here also we put tan inverse x equal to t. Now differentiate both sides. We know that the derivative of tan inverse x is 1 by 1 plus x square. Okay, so this becomes 1 by 1 plus x square dx equal to dt. So this term replaced by dt and tan inverse x by t. So the function becomes integral e raised to t dt. E raised to t dt. We know that its integral is e raised to t plus c. Finally, we replace t by tan inverse x. So the answer becomes e raised to tan inverse x plus c is the answer. The next question, integrate the function sine of 2 plus 3 log x by x dx. Here we put 2 plus 3 log x equal to t. Now differentiate both sides with respect to x. We know that 2 is a constant, so its derivative 0. And derivative of 3 log x is what? 3 into derivative of log x, that is 1 by x. So the left side become 3 by x equal to dt by dx, that is 3 by x dx equal to dt. Okay, now we transpose 3 to the right side. So this becomes dx by x equal to dt by 3. Okay, so the function become sin t dt by 3. So here 1 by 3 is a constant, take it outside. We get 1 by 3 integral sin t dt. We know that the integral of sin t is what? Minus cos t. So the answer becomes minus 1 by 3 cos 2 plus 3 log x plus c. The next question, integrate root tan x by 2 sin x cos x dx. Here we arrange the function as on the denominator, here we divide and multiply by the trigonometric term cos x. Okay, that is the denominator becomes 2 into sin x by cos x into cos x into cos x. Already we have a cos x on the denominator, so this becomes cos squared x, and the first term sin x by cos x becomes tan x. So here on the numerator we have a root tan x, and on the denominator we have a tan x. So a root tan x we cancelled. After we get 1 by root tan x. Okay, it is 1 by 2 into integral 1 by root tan x, and here 1 by cos squared x is what? Sec square x. So this becomes sec square x by root tan x dx. Okay. Now we check the derivative of the denominator d by dx of tan root x. We know that this is our numerator. So here also we apply the formula integral f dash of x by root f of x dx. Okay. Okay, so the function satisfies this formula. So the answer becomes 1 by 2 into 2 root tan x plus c. 2 cancel. After we get root tan x plus c is the answer. Okay. The next question, integrate sin inverse x by root of 1 minus x square dx. Here we differentiate the numerator sin inverse x. We know that derivative is 1 by root of 1 minus x square. Okay. that is integral f of x into f dash of x. This is another formula, integral f of x into f dash of x dx equal to 1 by 2 into f of x all square plus c. It's another formula. Okay, it's another useful formula. So using this formula, we get we know that here we choose f of x as sin inverse x and its derivative is 1 by root of 1 minus x square. So here the function is of the form f of x into f dash of x dx. So using this formula we get the answer as 1 by 2 into sin inverse of x all square plus c. The next question, integrate 1 by 1 plus e raised to x dx. Here also we slightly arrange the function as here we add and subtract the term e raised to x on the numerator. So this becomes 1 plus e raised to x minus e raised to x by 1 plus e raised to x dx. Okay, now we separate the numerator with the denominator. That is 1 plus e raised to x by 1 plus e raised to x minus e raised to x by 1 plus e raised to x dx. Okay. So the first term cancelled. After we get 1 minus e raised to x by 1 plus e raised to x dx. Okay, now we separate the integral as integral 1 dx minus integral e raised to x by 1 plus e raised to x dx. Okay, so the integral of 1 is x minus the second expression is integral e raised to x by 1 plus e raised to x dx. Here we check the derivative of the denominator. So we know that its derivative is e raised to x. That is a numerator. Okay. So here also we applied a formula. We have a formula. If the function is of the form f dash of x by f of x dx, then the integral value is log mod f of x plus c. Using this formula, the answer becomes x minus log mod 1 plus e raised to x plus c is the answer. Okay. Thank you. Hope you all understand the topic. Don't forget to subscribe my channel.